This
What are
conference will now be
identifiers
recorded.
are with us? So what are identifiers? Close all your books. Saturday, Sunday, holiday. Huh? What you have done? So tell me, what are identifiers? Huh? Hmm. So what are the rules to represent identifiers? What are the rules to represent an identifiers? Okay, that is the first rule. What are the other rules you are having? Python is case sensitive. Next. Variable names cannot be used as a keywords. Keywords cannot be used as a variable names. Next. We can use underscore for writing the variables. Special characters cannot be used. So how many data types we are having? 5 data types. So how we can represent a list? By using square brackets. Square brackets. How we can represent the tuples? Parentheses. So what are number data types? What are number data types? Integer, float. What is the difference between float, double and long double? Tell me. Double. After decimal point 15. Float 19. Long double is 19. Float is 6. Okay. So what are Boolean data types? So how Python interpreter internally works? By using how you will convert .py file to .pyc file. Online. Anybody can tell me? Online. What is the purpose of PVM? I am not asking about PEP. I am asking about PVM. Python. Bytecode to mission code. Okay. So let us see here operators. So what is an operator? An operator is a symbol. An operator is a symbol which is used to perform a task between operands. So this is nothing but an operator definition. So let us see here syntax. So what is the syntax we are going to use here? Operand, operator, and we are going to take here operand. So if I am taking here example a plus b, what I am going to take here? A plus b. So here, let us see here. Here a comma b or a comma b or operands, and plus is an operator. Plus is an operator. So this is the definition of a operator. So what is the definition of an operator? An operator is a symbol which is used to perform a task task between operands is called operator. So what is the syntax to represent operator? Operand, operator, and operand. Okay. So see here, there are seven types of operators. Okay. So first one is nothing but arithmetic operators. So let us see here how we are going to represent arithmetic operators. Just wait. So one side you are giving it as an okay. One side you are going to take it as an operator. Another side you are taking it as an description. What we are going to take it as an description. So plus is an operator. So it indicates that addition. And next we are going to take here subtraction. What we are going to take here? Subtraction. So next multiplication. What we are going to take here? Multiplication. And you need to take here division. Okay. And you need to take here floor division. Floor division. So next I would like to take here exponent. What I would like to take here? Exponent. So all these are nothing but an arithmetic operators. Which operators? Arithmetic operators. If I am taking here ideally, so let us just see here how we are going to represent this ideally. If I am giving 89 plus 23, 45 into 23. So next 789 divided by floor division 12. So floor division means it will consider remainder divided value, but after decimal point it will round figure it. But floor division means it will consider least value, not the highest value. Okay. So next we are going to take here 340 some modulo 23. Modulo means it will consider remainder value. Okay. And 2 double star 3. That means 2 cube. Double star indicates that exponent. So it will be considered it as an power value. Which value? Power value. 6789 divided by 34. Okay. Division means it will retrieve coefficient value. Which value it will retrieve? Coefficient value. See, no need to declare any variables. Okay, no need to define any data types also. Directly you are assigning the values and operators or not. So like this you can represent all arithmetic operators. Just wait. This is I have to select with prompts. So example. Now write down. Did you completed the operator definitions? Why some people are not reading the subject? Huh? You are coming to classes regularly, but if you are not doing hard work, if you people are not doing any practice, then what is the purpose you people are coming to class? Huh? Sitting silently writing some notes. If you are going to home, that is enough to crack any interview. Huh? If you are doing like that, you will get a job. Can't you read 2 hours subjects in a 24 hours day? Having 24 hours in a day. If you sleep for 8 hours, whatever what you are doing for remaining hours. Huh? Eating and sleeping, Eating and sleeping makes you to get a good job. Huh? I'm not understanding why you people are not studying. One or two people are responding to me, but what about remaining people? For time pass, you are coming to here. So today I was giving warning for you. If I'm asking any question from tomorrow onwards, if you people are not responding, I won't continue this class. Understood or not? Huh? Did you written all the examples? Shall I go for next operators? Okay. So second one is nothing but second one relational operators. Which operators? Relational operators. So let us see here. If I'm taking table, so one side you are going to write it as an operator and another side description. What we are going to take here? Description. Okay na? So let us see here. One side you are going to take greater than. What we are going to take here? Greater than. Another side you are giving greater than or equal to. So you need to take here greater than or equal to. Okay. So next I would like to take here less than. What I would like to take here? Less than. So I would like to take here less than or equal to. What I would like to take here? Less than or equal to. Okay. So next I would like to take here. Okay, what is the next one we need to take here? Double equal to operator. So double equal to operator. So next we are going to give here not equal to. Not equal to. So these are the operators which are present in relational operators. So I want to show you some examples. But relational operators always returns boolean value. What it always return? Boolean value. Okay. So let us take here. So let us take here 67 greater than 23, 45 greater than or equal to 12, 56 less than 123, true. For suppose 89 less than or equal to 23, false. Okay, true or false. It will not retrieve any other values. 67 double 7 equal to 67. Both the values should be true. Okay, na? So next I would like to take here some 1, 2, 3 double equal to 45. Now it will be false. 1, 2, 3 not equal to 45. Now it will be true. All these are nothing but an relational operators. What you are calling it as an relational operators. Right now. This one is completed. Not completed. Boys are writing, just wait. Completed or not? Can I scroll it? Not only these values, you can give your own examples also. Okay. You know how to use relational operators, right? So that is the reason you can give your own values. Completed or not? Completed everyone? Up to here, everybody completed? Completed? Huh? Okay, fine. So next we are going to see here, next one, third one. Logical operators. So first one is nothing but an logical and. So logical and should be represented with. So here we can't use any special symbols, just a logical and. So let us take here when I am giving truth table. So here you are giving A, B, here you are giving A and B. Okay. So now I am giving here 0, 0. So it is going to return 0. If both the conditions are false, it will be false. Okay. So 0, 1. So it is going to return again 0. 1, 0. So in your childhood, you have learned about the truth tables or not? Same thing. So next I would like to take here 1, 1. So it is going to return 1. If both the conditions are true, it will be true. Okay. Example. So let us see here what I am going to take here. So again, so here see 45 greater than 12 and 89 greater than 34. So now it will be true. And 78 less than 23 and 89 greater than 123. It will be false. One is true, another one is false. Based on the truth table, true false means it is going to return false value. For suppose 345 greater than 123, false, and 90 greater than 12. 90 is greater than 90 is greater than 123. So both conditions are false. So then it will be false. So like that you are going to implement what you are going to implement logical and what we are going to represent logical and online. Everybody understanding or not? Online,
Yes,
everyone,
ma'am.
did you understand? Today is April 7th, right? When our batch started last Wednesday, na? Second, I think. Completed, Amma. Everyone, did you completed logical operators? Okay. So next, logical and is completed. Now B, you need to take here logical or. What is the operator we have to use here? Logical or. So let us see here. I would like to take copy just small changes. So here instead of and I would like to take here or operator. In or operator, any one of the condition is satisfied, it will be true. Okay. So let us see here example. For suppose I am taking here same examples but by using or operator. So now it will be true. Why? Because both conditions are true. If I am taking this value, now again it will be or operator. See, 78 is less than 23. False. 89 is greater than 123. Both are false. So it is going to return false. Okay. But here I am applying or. So see here 345 greater than 123. 90 is greater than 34. So one condition is false. One condition is true. Now it will be true. Any one of the condition is true, it will be true. Okay na? So then it can be called it as an logical or. What we are calling it as an logical or. Now write down. Completed, Amma. Shall I discuss last one in logical operators? Okay. So C, that is nothing but logical not. What we are going to discuss here? Logical not. So what is the truth table to represent logical not? So let us see here a, and you need to take here not a. So here you are taking 0 1, and here you are taking 1 0. Okay, opposite value. So example, for suppose see here in the ideally, for suppose what are the examples? See, these are very simple. So if I am giving not of not of not of 1, so 1 means true. So that is the reason it was returning false. If I am giving not of 0, 0 means false. Opposite value is nothing but true. Okay. Or you can give like this, not of true, it return false. Not of false, it is going to return true. Okay. So this is nothing but logical not operator. Every time it is going to return Which value? Opposite value. True means false, false means true. I open this also, but somewhat better I think. That side you can open. Second one. Door. I think very suffocating. Better. So next we are going to screen is visible, na? But here suffocating, na? If you can't open the door, it is very hot in the room. So okay, so next we are going to see here assignment operators. Fourth one, so that is nothing but assignment operators. So what are assignment operators? We will see. One side you are going to take here operator, and another side you are going to take it as an description. So let us see here. So here first you need to give plus equal to means add and yes sign. Next, minus equal to, so you need to take here subtract and yes sign. So multiplication equal to multiply and yes sign. So next, division equal to division and s sign. What we are going to take here? Division and s sign. So next I would like to take here modulo equal to. So here I would like to take modulo and s sign. Okay. So next I would like to take here uh, floor division equal to. So floor division and assign. Division and assign. So next I would like to take here exponent equal to. So here exponent and yes sign. So all these are nothing but operators which are present in assignment operators. So I want to show you some examples. So let us just see here. Just wait, you can write down. I will give you the time now, just wait. So run, you are going to take here Python shell. What we are going to take here? Python shell. So now if I am giving a is equal to 12, a plus equal to 34. So what is the meaning of that? A is equal to a plus. So that means 12 plus 34. Okay. So now, so no need to define any third variable or second variable. By using single variable only, you can print the addition of two numbers. So whenever you don't want to use any third variable, then we have to use this assignment operator. In the same way, s is equal to 45. So yes into equal to 12. So here I am taking print of yes. So you are giving here 540. So next d is equal to you need to take here 456. D division equal to 23. So if I am giving here d value, it was retrieving the division value or not. So like that you are going to represent all your which operators? Assignment operators. Which operators? Assignment operator. Enough three examples or shall I discuss more examples? Enough, na? Why? Because short form. See, normally when you are doing addition of two numbers, you need to take a value, b value, c is equal to a plus b. But when we are using this assignment operators, no need of using any third variable. So by using two variables or single variable only, we can define these operators. Okay. So write down. Online, everybody understood? Online. Everyone, did you understood or not? Completed, huh? Some boys are still writing. You are parallelly executing or not? Completed? Everyone, did you complete it? Okay. So next we are going to see here. Next we are going to say here. Fifth one, membership operators. Which operators? Membership operators. So in this, I would like to take here in. In means it is going to return true variable if a variable is in sequence of another variable comma else it is going to return false. So second one is nothing but not in operator. So what is not in operator? It is going to return true if a variable is not in sequence not in sequence of another variable not in sequence of another variable comma else you need to take here false. You need to take here false. Example I need to take. So let us take here ideally. So L is equal to, I am going to take here some fruits names. Apple, I am going to take here grapes, and I am going to take here mango, and I am going to take here kiwi. Okay, so now I would like to take here grapes in L. Yes, it is present, so it is going to return true value. For suppose any other fruit name you can give in L. So it is not present, it is no, it is going to return false. For suppose Goa, Goa not in L. So now it is going to return again true value. So like that we are going to use in and not in. Right? Membership operators. Completed everyone? Everyone, did you complete it or not? So next one we are going to see here identity operators. Which operators? Identity operators. Sixth type, identity operators. So in identity operators, the first one is operator. Which operator? Is operator. So returns true if identity of identity of two operands or same, otherwise else you will go to take here false. So next I would like to take here B, is not. What I am going to take here is not. Is not means I am going to take here returns true. Okay. If identity of two operands or not same, otherwise it will go to else false. Okay, so I would like to take here example. So let us see here how we are going to represent identity operators. How we are going to represent identity operators. So here I would like to take, for suppose A is equal to 45.67. If you are giving here type of S, it is a float. Okay. So type of yes is float. It is going to return true. But if you are giving type of yes is int, it is going to return false. If I am giving type of yes is not int, yes, it is true, so it is going to return true. In such cases, we can use is operator. Which operator? Is operator. Right. Identity operators. So every day it will be like this only. Some what we can say, definitions, examples. Definitions, examples. So by that you will have a flow of your subject. You can understand easily. If I am telling only practical session, what will be happen? You don't know the definition. Am I right or wrong? So this is the big. So no need to worry, we will cover everything. So we left with one more operators. If you make it fast, we will discuss. Oh my god. Completed? Everyone completed? Okay, fine. So last type of operators. So that is nothing but bitwise operators. So what are bitwise operators? First one is nothing but you are going to take it as an bitwise ent. Okay, so it should be represented with a single ampersand. See, for bitwise end operator, what is the truth table you are having for logical and the same truth table will be applied to bitwise operators. Which operators? Bitwise operators. See, instead of end, you can give here ampersand symbol. Which symbol? Ampersand symbol. So now I am taking here paint 5 because I need to explain one diagram. Okay. So I am going to take here paint. Okay. So here I would like to take here and na bitwise end. So here I am taking a value as a is equal to 10 value. You need to convert 10 into bits. How you need to convert 10 into bits? So okay, so let us see here. 1 minute. 1 minute. So here I am taking 10 value. You are dividing this 10 value with 2. Binary bits, na? 2. So that is the reason every time you need to divide it with 2 value only. 2 5s are 10. So nothing to return. So it is going to return 0. But 2 2s are 4. So again it is going to return 1. So next 2 ones are 2. So 0. So if you are taking this value in upward direction, the 10 value is nothing but 1010. Understood or not? So next you are going to take here which value? B value. What you are going to take here? B value. B value I am assuming it as an 7 value. Which value? 7 value. So 7 should be divided with 2. So 2 3s is 6. So remainder 1. So 2 ones are 2. So 2 ones are 2. So again it was carrying 1. Okay, na? If you are taking in upward direction, so what is the value you will get? Triple one. But one value is less. So that is the reason before triple one, you need to add a 0. What you are adding? 0. Now here you are getting AB values. Now what is the A value? Tell me. What is the A value? So 10110. So now see here example. What is the A value here? A is equal to A is equal to A is equal to 10. So you are getting a value like 1010. So B is equal to 7. So equal to 0 1 1 1. What you are getting here? 0 1 1 1. So now if you are taking here Uh, what is the operator we have to use? A and B operators. Based on the truth table, if you are giving here 10, logical and truth table, 10 means 0, 01 means 0, 11 means you are getting here 1. So next I would like to take here 101 means again 0. Okay, so now see here 0010 you are getting, just wait, 00, what you are getting? 10. Okay, 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3. So 2 power of 3 means 8 into 0 plus 4 into 0. 2 power of 1 into 1, 1. 2 power of 0 into 0, so that is nothing but 0. Finally, what is the value you will get here? 2 power of 1 means, sorry, here you will get 2. So 8 into 0, 0. 4 into 0, 0. So it will remain with 2 value. See, if I am going to, ideally, if I am executing 10 and 7, you are getting 2 value or not? Right? Just wait. Mm, example, here you can write down, this will be like explanation. Okay, so write down bitwise end. Did you understood bitwise end or not? Everyone, did you understood? Remaining we will discuss in 11 o'clock class. Why? Because bitwise operators are not completed. Bitwise or bitwise exclusive or bitwise complement, shift left, shift right, all these are there. Okay, and after that we will discuss about control structures. What we will discuss about control structures. If any concept is there we will discuss, otherwise we will discuss about control structure. We need to complete our syllabus by next month 10th or 15th. Understood or not? Already 7th. So we are having very less days. So tomorrow also you are having class like 9 to 10 and 11 to 12. Understood or not? Tomorrow also at what time you are having class? 9 to 10 and 11 to 12. Okay, na? We need to cover a lot of syllabus. That is the reason. Completed. Now in paint I have given explanation how you are getting 10 and 7 values. Write down. Why? Because the same values I will use it in logical or logical exclusive or, and bitwise complement, shift left and shift right. Understood, Amma? Completed this explanation. See, the people who studied at CSC or Triple E students or EC students know about this conversions. If you are taking any integer value, you need to convert it into bits. On bits only we can apply this bitwise operators. So when you are implementing bitwise operators, we can't use strings, we can't use floating point numbers. We will use only integer values. Understood, Amma? So this is all about your operators concept. At 11 o'clock, we left with some operators. Na? We will discuss in 11 o'clock. Okay. Okay. Bye. Bye for now. We will meet it again 11 o'clock with the same link. Online people, you can join with the same link. Bye. Oh, I should. Anybody having any other classes? I think only one person. Go. If you want to people sit here, you can sit. No problem.